Hi, for our third day we're going to take a look at both the isosceles triangle and equilateral triangle. And just a quick little reminder from the first day of this chapter, an isosceles triangle is a triangle that has two equal sides, and an equilateral triangle is one that has three equal sides. Now, the next thing that we're going to take a look at is the isosceles triangle and just kind of explore it a little bit. Now, down here it says, is triangle ABC isosceles, and then why? So what I'm going to do first is measure. It would make sense to measure the length of the sides, A to B, B to C, and then I'm also going to measure A to C just to make sure that it's not equilateral. So what you should notice is that we have two sides that are equal. Now, the other thing that I want to mention is that not only do we have two sides that are equal, but we also have two angles that are equal. So if I measure the three angles of this triangle, I end up with two angles that are the same and one angle that's different. I'm just going to move everything to the right place. Now, one thing, just quickly, I do have two angles that are the same. Those two angles are actually the angles that are across from the two sides that are equal. So, if you're trying to figure out where the sides are and where the angles are that are equal, if you know the two sides, go across, and those will be the angles that are equal. If you know the angles that are equal, go across, and that will give you the sides that are equal. So, why is this triangle isosceles? It has two equal sides and two equal angles. Now, just as far as definitions go, the two angles that are the same, they are actually called base angles. So in an isosceles triangle, you have two base angles. Those are the angles that are the same. And then you have the angle on the top. That's the vertex angle. All right. Next one. It says in triangle ABC, measure the three angles. And what do you notice? So if we, again, just measure the angles for this one, Alright, so again what we should have are two angles that are the same and one angle that's different. So what we want to do is figure out which angles are the base angles. Well, the base angles are the ones that are the same, so that would be angle A and angle C. And then the second part says, what is the vertex angle? Well, the vertex angle is the one that's different. In this triangle, it would be angle B. Okay, next one. What we want to do here is construct a median, an altitude, and an angle bisector from B to AC. So let's review. Median is a segment that goes from a vertex to the midpoint of the opposite side. So first thing I'm going to do is construct a midpoint on that side and then draw a segment that goes from B to the middle of AC. Now, altitude is the height. Altitude is always perpendicular to the side and it goes through a vertex. So I'm going to choose perpendicular. I want it to be perpendicular to that side and I want it to go through B. And then the last one is an angle bisector. So again, I'll go to construction and choose angle bisector. I'll outline angle B because that's the angle I want to bisect. And then what do you notice? Well, all three of those segments, the median, the altitude, and the angle bisector, actually are the same segment. That does not happen all the time. Okay? It only happens when you have two sides that are the same. So if you're drawing a median, an altitude, and an angle bisector through the middle of an angle where those two sides are the same, then they will be the same exact segment. Okay, so in a triangle, if two sides are congruent, then the opposite angles are congruent. Okay, so again, if we have two sides equal, we have two angles equal. And in a triangle, if two angles are congruent, then the opposite sides are congruent. Okay, that sounds an awful lot like a theorem or a postulate. So that is something that you can use when you're writing a proof. If you have an isosceles triangle, then you have two angles that are equal or two sides that are equal. If you know that you have two angles that are equal, then you will have two sides that are equal. Okay, next one. Is DEF an equilateral triangle? Well, again, we'll measure just to see. It might just look good. So again, I'm just going to measure the length of the three sides. And the three sides are the same. So, is it an equilateral triangle? Yes. 3 equal sides. Now, next thing we want to do is measure all of the angles inside triangle DEF. So I will get my angle measurement tool and measure all three angles. Now, this is actually something that we did on day 1. On day 1, I had you construct an equilateral triangle and measure the angles. So hopefully this is nothing that is shocking, just a little bit of review. So again, all three of those angles turn out to be equal. So what do we notice? All angles are equal, and they are all 60 degrees. Again, every single time you have an equilateral or equiangular triangle, all three angles inside of that will always be 60 degrees. Each one will be 60 degrees. Now, what we want to do again is construct median, angle, bisector, and altitude for triangle DEF. Now, we can pick any side that we want to work on. So I think I'm going to go from F to DE. So the first thing I'm going to do is construct a midpoint on DE, and then draw in that segment. So that's my median. Then I'm going to do an altitude, so a line perpendicular to DE that goes through F. And then I'm going to construct an angle bisector at angle F. So I will outline angle F, and there's my angle bisector. And again, all three of those are the same segment. Now, I said that only happens when two sides are the same. Well, I said it only happens when the two sides around your angle are the same. So right here, if this is an equilateral triangle, FE and DF are the same length, so the median, altitude, and angle bisector will all be the same segment. If I go over here and I grab point D and I move it around, okay, I've constructed it so that it is always an equilateral triangle, and so they always will be the same segment. Okay, so in an equilateral triangle, all angles are 60 degrees. Now, last thing that I want to do for today is construct an equilateral triangle. Again, we did this back on day 1, but I just want to make sure that you know how to do it because the construction piece is kind of a big deal. So, first thing you want to do is start off with a segment. And your segment can be anywhere. And then you want to grab your circle tool. So we'll go into shapes, grab circle, click on one point, one endpoint, and then click on the other. And then do the same thing backwards. So click on the last point you clicked on again, and then go back to the other. Now, where those two circles intersect is going to be the top of your triangle. So I'm going to put a point there. I'll actually put an intersection point where that circle and that circle meet. And then that point is the top of my triangle. So now I'm going to get my segment tool, and I will construct a segment from each of the other endpoints up to the top. So there's my equilateral triangle. Now, the next thing I'm going to do is just hide those circles because I don't need to see them. So I'll go to Hide Show, click on one circle, click on the other, and then I have this point down here that I'm going to hide also. And then just hit Escape, and there's your equilateral triangle. If you grab a point and you move it around, it will always be equilateral. It doesn't fall apart. So that's it for day 3.